So today we will be going through the basics of first unit, okay? And that will be on the determinacy and indeterminacy, right? So let me share my screen. So I hope my screen is visible to all of you. Is it visible? Please respond. Okay. Okay. So the first topic is determinacy and indeterminacy, right? So the first one is determinacy, right? So basically there are two types of determinacy. One is statically uh, determinate structures, and the other one is indeterminate structures, right? ठीक है? So statically determinate structure का मतलब क्या है? So it means that we can solve these structures with the help of equilibrium equation, right? So what are those equilibrium equations? Anyone? Neha? What are the different equilibrium equations we have? Can you tell? What are the three different equilibrium equations which we have? What are those equilibrium equations? Those are three equilibrium equations, right? They are three in numbers. And what are those? That is summation of fx equals to 0 and summation of fy that is equal to 0 and summation of m. Summation of m equals to 0, right? This I hope you have learnt in your essay 1, right? The first unit, right? Satyam Meher, is he registered for structural analysis 1? अभी ये वर्क करके तो मुझे अलग दोगे तो थोड़ा सबमिट कर दोगे ना Only I think only 3 students have registered for structural analysis 1. इधर उधर मत देखो सभी ऑनलाइन कोचिंग जो है पैरेलल चलता है ठीक है सभी ऑनलाइन कोचिंग पैरेलल चलता है 19-20 का अंतर रहता है एक तो टीचर रहता है जो कि मतलब 19-20 का अंतर करता है ये सभी पैरेलल ओके नो इश्यूज right okay so let's come back to the topic. So we have three equilibrium equations, right? Summation fx equals to 0, summation fy equals to 0 and summation of moment equals to 0. So statically determinate structures are those structures which we can solve using these three equilibrium equations, right? Okay. So what are these indeterminate structures? These are the structures which require, apart from this equilibrium equation, they need some more number of equations in order to solve them, right? अच्छा, solve करने के लिए, so what do you understand when we say analyze a structure? What do you understand by when we say that we have to analyze this structure? Analysis of structure से क्या समझते हो? और when we say analyze this simply supported, ठीक है? Let's take a simply supported beam, right? So this is my simply supported beam. Just a moment. बोलिए
सर इतना डिटेल्स में मत चाहिए ये कीजिए करके एक दो प्रॉब्लम ये करके बोलिए कि क्या प्रॉब्लम है क्या तुम लोगों को दिक्कत हो रहा है समझ में ये ऐसे करके चाहिए।
ठीक ठीक okay see. So we have this simply supported beam. अब इसको analysis करने में it means that we need to, so let us say it has got a point load, for example let us say the point load is P, the length of the beam is L, right? So if and this P is applied at a distance of L by 2, right? If it is applied at a distance of L by 2, then when we say that analyze this structure, it means that we need to find out the reaction forces and the moment, right? The moment at any cross section, right? So if this is a simply supported beam and we have one point load here, then what will be the reactions? Reaction क्या क्या आएगा? नेहा, इसमें क्या क्या रिएक्शन आ सकता है? So let us say this is my support A. Huh? Yes. Neha, what did you say? Yes. So there will be two reactions. That is, let us say the reactions are RA and RB. Right? Okay. So what will be RA and RB? So if we see now, which type of structure is this one? Which type of structure is this one? Hello. हाँ. Good morning. तो ये स्ट्रक्चरल एनालिसिस मान में रजिस्टर करছো? अच्छा ताहले ये जल्दी आउथरे ये पठा रिक्वेस्ट आउथरे पठा हाँ fine. So this RA and RB we can find out this RA and RB using this equation, yeah, this summation of Fy and summation of moment equals to 0, right? So how we can find out that one? That so the first equation if I will use, that is summation of Fy equals to 0. If I use that one, if I use mm, that one, so if I use that one, then Ra plus Rb, right? The vertical reactions Ra plus Rb, that will be equal to P, right? So this implies, can we proceed further in this one by using only Ra plus Rb equals to P? No. Why? Because this. So in order to solve these two equations, I need. Sorry. In order to solve these two unknowns, I need two equations. Right. Okay. So what I can do? This is my first equation, and using the this equation, the second equation, moment about or moment equals summation of moments equals to 0. So what I will do, I will take the moment about B or I will take the moment about A. Any one I will do and I can find out what are the reactions, right? So if I taking moment about B equals to 0. If I take moment about B, right? Taking moment about B.
what I will have. Neha, can you tell what equation I can have if I take moment about B? If I take moment about B, next, Shantanu, can you answer? If I take moment about B, what will be my equation? Hmm? What will be my equation if I take moment about B? It will be RA into L minus P into this distance, right? So when you so what is this distance? This distance is L by 2. If this is L by 2, then definitely this will be L by 2, right? So RA into L. So if I take moment about B, so RA into L minus, because this RA, it is making which kind of moment? If I take this as support, so this force will be making a clockwise moment, and this force, it is making an anti-clockwise moment. So if, right, so if this is my point, then so RA is making this one, and this P, it is making an anti-clockwise moment, right? So if I will consider this, the first one as positive, if I will consider the anti-clockwise, I will consider as negative, right? So RA into L minus RB, sorry, minus P into L by 2, right? Any other force is there about this point which will produce a moment? Is there any other force? No, right? This, you may say, sir, this force? No, because this force is passing through that point. So the perpendicular distance between the line of action of this force and this point is G, right? So that's why here RA into L minus P into L by 2, that is equal to 0. So from this RA into L, that equals to L by 2. So this L, so I can cancel this L and I can cancel this L. So this implies what will be RA? RA equals to P by 2. If RA is P by 2, how much is RB? You can see here I have the equation RA plus RB equals to P. So this is my input. So from 1 and 2, RA, so I have RA plus RB equals to P. So this implies RA value is P by 2 plus RB equals to P again. So this implies RB equals to P minus P by 2. This implies what is RB? RB is P by 2, right? Okay. So now see, we could able to solve this simply supported beam is with the help of this equilibrium equation. Why we could able to solve? Because this structure is a determinate structure, right? If it would have been an indeterminate structure, then we could not have only used this one. Apart from this equilibrium equation, we would be requiring other equations in order to solve this one, right? So let's see why this structure became, why this simply supported beam became a determinate structure. Let's understand this. So This is my again that simply supported beam, right? What made this structure as a determinate structure, right? So for the simply supported beam, here I have a point here, right? And it is at a distance of 12 by 2, right? Now when we call this structure to be a determinate structure, okay? So in order to solve the determinacy, we do have formulas, right? So first one is external indeterminacy. External indeterminacy and internal. External indeterminacy and internal indeterminacy, right? Okay. So external indeterminacy, what is the formula for external indeterminacy? It is external. Let us say E represents my external indeterminacy and I represents my internal indeterminacy. So for a simply supported beam, not only for a simply supported beam, for any structure, right? The external indeterminacy is represented by capital R minus small r. So what is this capital R? Capital R is number of unknown forces, right? And what is small r? Small r is number of equilibrium equation, right? So how many equilibrium equations? Okay. Now who can tell the answer to this question? So if R is number of unknown forces, so what are the unknown forces here? Who can say? Satyam, can you tell what are the unknown forces in this uh, simply supported beam? What are the unknown forces? Huh? Satyam, yes, I couldn't able to hear you. A and B. What is A and B? A and B are the supports, right? So what are the unknown forces? What are the unknown forces? The unknown forces are the reaction RA and the reaction RA, right? Okay. So how many unknown reactions we have? How many unknown reactions we have? Okay. Now, before we go to this portion, let's understand. Okay, let's understand the types of support. Right. The first one is ruler support. Second one is hinge support. Third one is, what is the third support? Fixed support. Right. Okay. So how many reactions will be there for fixed support? How many reactions will be there? कितना reaction आएगा? Unknown reaction. Remember, for fixed support, I will have three unknown reactions. One is vertical force, one is horizontal force, and another one is the moment. Right? So remember, so for a fixed support, the number of unknown forces, the number of unknown forces will be for fixed support. It will be. Let's talk about the hinge support. So how many unknown forces will be there for a hinge support? it will be 2. One vertical, no. For a hinge support, it will be 2. One vertical, one horizontal. Right? Okay. So that's why the number of unknown forces for a hinge support will be 2. Right? What about the roller support? Because this roller support, it will have a reaction in the vertical direction. This roller can move from left to right. Okay, so that's why here only the vertical reaction will be there. The horizontal reaction is, or the horizontal force is not at all used to. So that's why the number of unknown forces will be for a roller support it will be 1. Okay. So now tell me. So see here, we have taken a fixed support, we have discussed about hinge support, and we have also discussed about the roller support, right? So in this case, what will be the number of, what will be the reaction forces? How many reaction forces will be there? It will be RA and RB, and one reaction force will be there, that is HA, the horizontal, right? But since this is a case of beam, so we can neglect this one. So if we neglect this horizontal force, again the number of equilibrium equation will be from 3, it will be 2. Okay. Okay. So let's consider that here 3 unknown reactions are there. So what will be the external indeterminacy for this simply supported beam? E equals to what is R? Capital R. Capital R is number of unknown forces. So how many unknown forces we have? HA, RA and R. Right? So capital R is how much? 3. Right? And what about small r? Small r is the number of equilibrium equations. So how many equilibrium equations we have? We have 3 number of equilibrium equations we discussed here, right? Those are summation of fx equals to 0, summation of fy equals to 0, and summation of moment equals to 0. So these are the 3 equations which we have. Okay. So my external indeterminacy becomes 3 minus 3, that is equal to 0. Right? Okay. Now, what about internal indeterminacy? The internal indeterminacy of this structure is I equals to 0. Now remember, why I equals to 0? Because for beam, there is no internal indeterminacy, but we have internal indeterminacy for truss, for frame source, right? Okay. Now let's see whether you can tell the answer for the next question or not. Right? So let us say I have beam like this. One support is hinged, another support is fixed. So what is the degree of external indeterminacy? What is the external indeterminacy for this one? Let us say this is, what is E? External indeterminacy. This is my support A, this is my support A. You can take something. Can you hear my voice? Please respond. Okay, so what is the external indeterminacy for this top cantilever? So how many unknown reactions we have? How many unknown reactions we have? We have how many reactions for huh? A, and what about C? I told right, for in support how many unknown reactions will be there? Yes, total 5 unknown reactions. One RA, one HA, horizontal one, and for the fixed one, RB, HB, and MB, moment. So what will be the external indeterminacy? E equals to r minus r, right? So what is r? Capital R, 1, 2, 3, 4, 5, right? And what is small r? Small r is always 3. Small r is always 3. So my external indeterminacy is 5 minus 3 is 2. It means this structure has two number of reactions which are extra or which are above the equilibrium equation. So that's why this mean is indeterminate. Means using the equations of equilibrium only, we cannot solve this kind of mean. Right? We need some other equations apart from the equilibrium equation in order to solve this. Okay. Now let's take one more problem. This is my fixed V, right? So, Rohit, can you tell what is the degree of indeterminacy, external indeterminacy for this structure? 6 unknown forces. Good. What are those 6 unknown forces? Can you tell? Yes, RA. Yes, RA, RB. HA, HB. Yes. Yes. And NA and NB. Right? Good. So external indeterminacy becomes R minus R. So that is 6 minus 3. That is 3. So it means this structure is indeterminate, is externally indeterminate to a degree 3. Right? Right? So this is about the okay. So if I ask what is the degree of internal indeterminacy of the structure? Internal indeterminacy is I. So what is the internal indeterminacy? I told you that the internal indeterminacy for beam will be always 0. So that's why for this one, for this structure, the internal indeterminacy is 0, and for this structure again, the internal indeterminacy is also 0. Fine? Okay. Right? Okay. So shall we move to the next type of structure? Shall we move to the next type of structure? Okay. So let's understand this. So for example, let us say I have a frame. We call this as a frame, right? So for this frame, let us say this is A, this is B, this is C, and this is D. Now can you tell me what is the external indeterminacy for this structure? आपको ये ऐसा हो गया. So how to find the external indeterminacy of the structure? Again we will go back to the same formula. E equals to R minus R. So what is capital R? Capital R is number of unknown forces. So इसमें बताओ unknown forces कितना आएगा? How many are 4? How 4? This is a fixed one. This is a fixed one. Yes, 6. So this is RA. Let us say the vertical reaction here is RD. Let us say the horizontal reaction is HA. Let us say the horizontal here is HB, and the moment NA and NB. Right? Okay. So again it will be R minus R. So what is capital R? 6 minus what is small r? 6 minus 3, that is 3. So again this structure is externally indeterminate to a degree 3. Okay. Now what is the internal indeterminacy for this structure? for frame? What is the internal indeterminacy? Remember, for a frame, this kind of structure, I, that is internal indeterminacy, that is equal to what all A. So what is this A? A is the number of enclosed cells. Enclosed मतलब ये जो अंदर वाला structure ये close होना चाहिए. Is this close? No. If suppose there one more horizontal member would have been there, then we call the or we say this one to be closed, right? Okay. So for this frame, ऐसा एक frame है, right? So here the internal indeterminacy I equals to 3 into how many number is there? It is only enclosed structure is 1. So 3 into 1 that is 3. अच्छा इसका बताओ क्या होगा? What is the internal indeterminacy for this plane, this frame? Only this one. What is the internal indeterminacy? Is there any? Yes. Since it is not there, it will be 3 into 0 that is 0. Right? Okay. That's it. Let's move to the next one. SX. Right? SX structure. What will be the internal indeterminacy for this one? Yes. It is 3 into 4. Why? Because enclosed surface 1, enclosed surface 2, enclosed surface 3, enclosed surface 4. Right? That is 12. So the degree of indeterminacy for internal indeterminacy for this structure is 12. Right? Okay. ठीक. अच्छा. एक्सटर्नल इंडिटर्मिनेसी हो गया, इंटरनल इंडिटर्मिनेसी हो गया, बीम और फ्रेम दोनों का हो गया, राइट? ठीक है. So let's go to the next type of structure, that is truss. You might have seen this kind of structure when you will be crossing through railway bridges, right? ऐसा वाला structure railway bridge के ऊपर जाते हुए, then you might have seen this kind of structure. So this we call it as a truss. So let us say this truss is having one ruler support and one hinge. Okay. We'll slowly go to or we'll slowly complicate things. Alright. Let's make it in this way. Let us say I have this way, two way this one, right? ये ruler support, right? So इसका external indeterminacy, what will be the external indeterminacy for this one? Let us say this is my A, this is B, this is C, this is D, this is F. Again, yes. So external indeterminacy is how it is 3. The unknown. Yes, good. So it is RA, it is HA, it is RB, right? Right? Yes. So R minus R again. So what is the formula? What is the value? Unknown reaction is RA, HA, yes, 3 minus 3, that is equal to 0. And what about the internal indeterminacy for a truss? Now remember, for a truss, the internal indeterminacy is n plus, no, for truss, yes, for truss it will be different. Okay? So it is n plus r minus 2j. So 2j. So what is n? N is number of members. R is again number of, what is smaller? equilibrium equation. And what is J? J is number of joints. So how many joints are there? You can tell. M is, see, M is number of members. M is the number of members. R is the number of equilibrium equation. J is the number of joints. So how many members are here? You can tell how many members are here. 1, 2, 3, 4, 5, 6, 7. Right? All of you, are you satisfied or do you agree? This person has got 7 members. All of you agree? Okay. So my number of members is 7. And what about number of equilibrium equation? Equilibrium equation, it is always 3. Right? So 7 plus 3 minus 2j. J is number of joints, right? So how many number of joints are there? How many number of joints are there? This is one joint. This is one more. This is one more. This is one more. And this is one more. Right? So it is 2 into 5. Right? So 7 plus 3 is 10. Minus 2 into 5 is again 10. So 10 minus 10, that is 0. So the internal indeterminacy for this truss is 0. It means that the degree of indeterminacy, internal indeterminacy for this truss is 0. Okay. So let's take another example of a truss. अच्छा इसका बताओ. Let us say it has got in support here and here also. For example, or ruler support here. At these two places, for example, it has got the ruler support. इसका indeterminacy बताओ. What is the external indeterminacy for this one? Let us say this is A, B, C, D, E, F, G. और E ना करके इसको दे देते हैं K से. So इसका external indeterminacy कितना होगा? 6 minus 3, 3. How it is 6 minus 3, 3? Because here 2 reactions, here again 2 reactions, and here 1 reaction, here 1 reaction. So it is 6 minus 3, that is 3. So what will be the internal indeterminacy? 0. I equals to n plus r minus n plus r minus 2j, right? So how many number of members are here? You can tell. 11, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So number of members is 11. And what is small r? What is small r? 3. That is number of equilibrium equation. And what is j? J is number of joints. 1, 2, 3, 4, 5, 6, 7. Good. So 2 into 7. So that is 11 plus 3 is 14 minus 14, that is 0. Good. Right? Okay. Right? Now, if I tell what is the indeterminacy of not I'm not talking about external indeterminacy, I'm not talking about internal indeterminacy. If I say what is the degree of static indeterminacy for this trust, what will be your answer? External indeterminacy हो गया 3, internal indeterminacy हो गया 0. So I am asking what is the degree of static indeterminacy for this structure? So degree of static indeterminacy. What is the degree of static indeterminacy? That I say as d psi equals to, it is a sum of external indeterminacy and internal indeterminacy. Right? Now, you can tell what is the degree of external indeterminacy for this truss? It is 3 plus 0, that is 3. So the degree of static indeterminacy for this structure is 3. Okay. So let's go back. Now, can you tell what is the degree of static indeterminacy for this one? What is DSI? Static indeterminacy is, it is 0 and 0. So that is the degree of static indeterminacy is 0. So let's go back again to this one. What is the degree of static indeterminacy for this frame? It is E plus I. So it is, yes, it is. So E is R minus R plus, this is internal indeterminacy, we have already calculated 12. So it is R is 3 unknown reactions here, 3 unknown reactions here. So 6 minus 3 plus 12. So it is 6 minus 3 plus, so this is 3 plus 12, that is equal to 15. Right? Good. So what is the degree of static indeterminacy for this one? For this, what is the degree? It is 3, right? Good. So it, because the internal indeterminacy is 0, external indeterminacy is 3. So that is 3 plus 0, that is equal to 3. Good. अच्छा, इसका बता, इसका क्या होगा? What is the degree of static indeterminacy? So we will always put the formula. बताओ क्या होगा इसका? For a fixed, it will be again 3. 3 plus 0, that is, right? Good. Okay. So this covers your determinacy and indeterminacy. अच्छा ठीक है. Let's go a little bit further. ठीक है? I have a frame like this. Right? बताओ इसका डिग्री ऑफ एक्सटर्नल, पहले बताओ एक्सटर्नल इंडिटर्मिनेसी कितना है, देन बताओ इंटरनल इंडिटर्मिनेसी कितना है, देन यू टेल मी व्हाट इज external is 2, 1, 2, 3, 4, 5. So external is 5 minus 3, that is 2, and external is 3 into 8. So 1 is here and 2. So 3 into 2, that is 6. So what is degree of static indeterminacy? It is 6 plus 2, that is 2. Right? So now I hope you can solve, you can find out the degree of static indeterminacy for any structure. Right? Okay, good. Okay, so almost we have covered From your first unit, today we have covered almost 33% of your first unit. आधा पहला यूनिट का 33% आज खत्म हो गया. Right now we are supposed to go learn the moment area method and conjugate name method. Okay, right? Okay, so do you want to shall we continue in online class or you want to come for offline? What do you say? Online will be better. Can you understand? Okay, okay then. So we will continue in online mode, right? Any doubts? Any doubts anyone is having for today? No. Rohit, I नोट्स वगैरह अच्छा यदि ମୁଁ notes share କରିବା ପଛରେ ମୁଁ notes ରେ ଯାହା ଯାହା ଅଛି ମୁଁ ସେଇଟା share କରିଦେବି ଆଉ ଠିକ ଅଛି ହେଲା ନହେଲେ ମୁଁ ଦେଖିବି ଯଦି କୋଉ ଗୋଟେ particular book ରୁ ହବ ତାହେଲେ book ରୁ ସେ portion ଟା share କରିଦେବି ଠିକ ଅଛି अच्छा सुन so uh, so so in this first slide I talked about types of determinism, right? So it is, or we can say that let's talk about types of structures, right? So structure ka, so there are two types of structures. One we call it as statically determinate structure, and another one is statically indeterminate structure. Okay? So statically, so what are those structures which are called statically determinate structures? Now those structures which we can solve using the three equations of equilibrium, that is summation of fx equals to 0, summation of fy equals to 0 and summation of n equals to 0. So those structures we call it as statically determinate structures. Okay? Now what are indeterminate structures? So indeterminate structure are those structures which we cannot solve using only the equations of equilibrium. We will need other equations which are called as compatibility equation along with the equilibrium equation to solve. Okay? In short, if I say the degree of or the indeterminate structures are those structures where the degree of static indeterminacy is greater than 0 and statically indeterminate structures are those structures where the degree of static indeterminacy is equal to 0. ठीक है बस यही वाला क्वेश्चन I told in the first slide and again I took this problem, right? So let's solve that one again and we will wrap it for today. And see, after every class, yeah, I will share the notes which portion I cover, okay, and we have to go through that one because see, we have very much less duration to cover, right? So we cannot cover all the topics just like we did in regular class. So what I will do, I will teach you the important concepts and I will give you problems on based on that one, right? Okay, fine. So अच्छा अभी ये जो so the problem which we solved, I am doing it again for Shantanu because he joined late and please make sure that from next class you will join on time, right? अच्छा this is for everyone. If you pay attention, you will understand this. Okay. So this is a simply supported beam, and in this simply supported beam, I have a point here P, which is acting at a distance L by 2, right? Okay, let us say the total length of this beam is L. Okay, so what are the reactions here? You can tell the reactions are, so one vertical will be RA, another vertical will be RB, yes, and since this is a hinge support, there will be a horizontal reaction HA, right? Okay, so how to find out HA, RA and RB? Okay, in order to, so these are vertical forces RA and RB, right? So we have three equations: summation of Fy equals to 0, summation of Fx equals to 0, and summation of moment equals to 0, right? Okay, so let's take the help of these equations and solve this one. So if I take summation of Fy equals to 0, means forces along vertical direction equals to 0, then what are the forces I have? I have two forces, or I have two forces, that is Ra plus Rb equals to 0, sorry, not equals to 0, it is Ra plus Rb equals to, this one is P, right? So Ra नीचे से जा रहा है, Rb नीचे से जा रहा है और P ऊपर से आ रहा है, right? If I take summation of Fx equals to 0, then what are the horizontal forces? That is summation of और HA equals to 0, right? इसके HA के साथ और कोई horizontal force है? No. So HA is equal to 0, right? Okay. Now what about moment? So in order to find Ra and Rb, I can take the help of the third equation, that is summation of moment equals to 0. So it is Ra into L minus P into, so if I take moment about this point, so it is making a clockwise moment, so Ra into L minus P into L by 2, that is equal to 0. This implies Ra equals to L cancel हो गया, Ra equals to P by 2. So if Ra is P by 2, what is Rb? Rb equals to, if I put the value, P minus P by 2, that is again P by 2. Okay, right? Fine, I hope it is clear to all of you.
म्यूट करके बात कर रहे
हाँ
हैं,
बोलो
म्यूट करके बात कर रहे
नहीं नहीं बोलो बोलो
हैं। आप थर्ड एंड फोर्थ स्लॉट ले रहे हो ना सबमिशन का?
हाँ right, is it clear to all of you? सबको समझ में आया? Okay, ठीक है. So okay, have you taken down the notes which I taught now? Have you taken down, or shall I share this one? Okay, okay, I will share this one. See, but apart from that, I will share from the book, right? So that you can prepare for unit for your exams also. Fine. Okay. So in the next class, we will go to, we'll take the easier one. Either we will take momentary method, or I will take, or we will create a conjugate beam method, right? It is better if you go for conjugate beam method, right? So in the next class, conjugate beam method, right? So this we will take in the next class. So all of you, please make sure that you join the class in time, okay? Right? And okay, okay, that's it. Thank you guys. You can leave now.